Thank you, guys. And I know it's a late hour, but let's start with a joke. As you see, Kubernetes and the function are still a bit dizzy when they come to the bar. And you know, what is the term of called drinking before getting into the pub? Anyone know? What's the term? Any guess? It's called pre-gaming. So it's a little bit funny, yes, but drinking up before the bar. So a bit about Agmatics. Agmatics, in a nutshell, it's a data-driven company, agro-informatic company that focus on standardized information in field trial, which is one of the most important things when you conduct research and a trial, is to be able to standardize the data between different vendors, and this is what we're doing. My focus here is about how to write a function. Things evolve over time, from microservices into functions, and I think that the most important thing that we would like to do today is to be able to run a simple function with a simple business logic, run it, compile it once, and run it everywhere. And this is the foundation of function as a service. The serverless model, the basic of the serverless model, is on two different persons, the operator and the developer. The developer just wants to write an event-driven function. He wants to have a service-based functionality, and he wants it to be an open API, to be consumed by any other party. The operator wants to be as less as infrastructure as possible, to manage securely and pay only for the invocation he's doing. As we know, Lambda functions evolved dramatically over the years. And as you can see, from 19 to 21, it's evolved it's improved significantly. And this is technology here to stay. But of course, there is another part of the equation. It's that every one of us want to write and containerize things as a Docker. And this is a problem, and it was a problem till the end of by the beginning of 2021. Lambda functions on AWS weren't able to support running Docker containers. So for the last few years, there was a very huge debate between, do we need to go serverless or we need to go with container? And it was very different. I think that serverless, we understand it's much more than function when you're starting doing development. And this is what I meant to say, that in the AWS conference in the end of 2022, they had a support for running serverless AWS Lambda with a Docker container, which is, I think, ended the debate if we need to go with Docker containerized or we need to go with serverless. But we need to still understand that there is servers behind the serverless. There's a lot of orchestration and a lot of mechanism running beneath the invocation of just a simple function. And at this point, I think that we all say, okay, we have the standard de facto technology to manage compute and storage. It is Kubernetes. So I dare to you to say Kubernetes one more time and maybe solve this issue in the same way. Kubernetes is, again, de facto same as the Lambda function, as I said, is orchestrating and managing at least 50% of the production workloads when it comes to regards into compute. And it's a lot of stars and projects. Its funding has much more than $60 billion a year, and this is only from 2021. But as we know, we see Kubernetes everywhere. Why not write a function, okay, a Lambda function, as we all know, and running it under Kubernetes? Is it possible to write a function under Kubernetes and not just investing in specific technology like AWS Lambda? To do so, we need to ask a question for ourselves. Is there still things that need to be managed as part of the operator part in Kubernetes? Is it something that need to be, can be possible? And when we explore the current implementation of running Kubernetes over serverless, you see that beside of just writing the function, you need to write the Docker container and deploy it into some kind of registry. You need to expose the application endpoint with a service. You need to supply some kind of a load balancer and scaling up and scaling out. You need to do SSL termination, scaling to 0 if you want to optimize performance, Canary deployments, what kind of monitoring and metrics can you get. So currently, there is no good solution to use Kubernetes as an infrastructure for running serverless compute. And this is the things that we just mentioned right now. So at this point, I'm sure there is a solution in Kubernetes. I'm sure there is at least one project that you can install and work. The ecosystem has a lot of open source projects, sidekicks. One of them should solve this issue. And the answer was no. The service has been evolved over time. And if you see, Kubernetes has limitations when it's come to running serverless compute and a function as a service. And this is a gap that we need to solve. And this is where Knative came in mind. I think that we all agree that Kubernetes right now, it's amazing project, it's amazing ecosystem. But in fact, I think that we can conclude that Kubernetes right now is too complex, and it's in effect a platform to build platforms. Investment in Kubernetes, in the low level of it, okay, understanding all the moving parts, all the complexity, all the mechanism inside of it is really, really complex. So we're starting to get some more simplified model to manage our workloads and not just Kubernetes. And to do so, we introduced by Google, which also developed and introduced into the community Kubernetes in 2018, the project called Knative. It's an open source to manage serverless workloads in Kubernetes. And to do so, it contains three parts as part of the solution. There is Kubernetes as an infrastructure, Knative that you're serving your serverless workloads, and as part of Kubernetes, they also supply a very lightweight ingress controller called Courier that can supply and help you with everything with regards to SSL termination, load balancing, canary deployment, etc. And this is the ecosystem. Kubernetes is a solid solution to manage your code build. Kubernetes will be managed by your infrastructure team, and OSS contributors can contribute both to Kubernetes and for Knative itself. Kubernetes partners, as I said, it's developed in Google, but it's really, really active developed by VMware, by Red Hat, IBM, and SAP. They all invested in also the community itself. They have more than 11,000 stars in GitHubs in part of this project. And it was very, really excited that I think it was half a year ago, they submitted a request by Google to be accepted as a CCNF incubating project. This is a huge milestone for the product and for the Knative as an ecosystem, because it's accepted by the community as a project that could be fulfilled as part of the cloud native solution. And it's really, really important. As you see, this is a major notable milestone. There's a lot of releases, a lot of pull requests per month, 11,000 GitHub stars. This is an active project, and it's really, really accepted by the community, which is really important. So what's the foundation of Knative? It consists of a serving model, an eventing model, function model, which is the latest development from the project, and a CLI. What is the serving? The serving, and again, you ask, this session should be a very, very hands-on. If you want to install it, everything you need to do, if you have a managed Kubernetes or a Minikube or whatever you want to manage your Kubernetes asset, you have to install these three commands. The first one is CRD, to apply the language extension of on top of Kubernetes. And you need to apply both of the models. One of them is a serving, and the third one, as I mentioned, it is a lightweight ingress service. With just three of the commands, you have fully installed the serving model. And what it consists of? This is the object model. It consists of a service, okay? Don't confuse with the service of Kubernetes. This is a really simplified version. It's managing configuration, okay? Configuration managed by revision. What you can manage in configuration, of course, you can manage the Docker image. It's going to pull and serving the content. You can manage configurations such as scaling up and scaling down, canary deployment, etc., and a lot of other configurations you could set. And you need to set up the route. The route is telling the ingress controller, okay, I need to set up this new service with this configuration, and spinning up and tell the ingress controller to service under this route. So it's really, really very simplistic model. And how it's look like? Okay, so we have a Docker containers. We want to ship them with the Knative and apply a new version. We use a CLI, the CLI called KN, and it's really simplistic, just brew install, and you have a use CLI or any executables that you want. This is a really simple one. And all you need to do is just kn service, create your service names and reference into your image, the Docker image. And if you're going to see how the YAML looks like, because as we said, we're extending with CRD the Kubernetes itself, you see it's really, really simple. We have a metadata, the service name, and we have a configuration. Part of them is container image, just referencing into your Docker registry with your latest version. Very, very simple. Let's say that we have a new version that we want to push. How are we going to push a new version? This is also something that we're managing as part of the development lifecycle. And this is also very simple. You just setting up the YAML, updating the container registry, for example, in version 2, you apply it, or using the CLI, and you have a new version. This is, again, really simple. If you want to update part of the configuration, so let's say, for example, you want to update your blue-green canary deployments, okay, and say, I want to deploy all the blue, which means I want to go 100% to the new version. I just need to run the CLI and just update the tag and set the configuration as a key and a value. Again, very simple. If you want to see the revision list, and again, the revision list is the configurations that we manage, just you need to click KN revision list and see all the configuration. And for example, as you can see here, I have a Go application. And after running and setting the blue policy for our deployment, 100% of the traffic go to the new service. And as you can see here, 100% go to the traffic, which is in version 2. So we can get more information about what is going on in a cluster itself. You can describe the cluster and the application itself. We can see that we have an application, its study, where it started, and how much traffic or not traffic we're going to get. Another thing that we're talking about, serverless, is how you're going to manage a burst in traffic. Okay, so everything is okay and everything is fine when you have a traffic balance into what your customer is looking. But what's happened if you get a burst of requests? How Knative going to handle this one? And it's handled this one with a service called a pod autoscaler. A pod autoscaler, we're going to listen to your traffic, get into your ingress controller, and decide automatically, and also by your configuration policy, if you need to spin up more instance, in Kubernetes means more pods, in order to fulfill the burst in traffic. How are you going to do so? There is two modes. One mode is the number of requests in flight anytime. Okay, so it means I want to keep a steady rate of requests per second, 50 requests per second, 100% per second, and more. And another thing is saying in another level of the architecture, I want to know how much request getting into a specific pod, okay, let's say the logical hardware, every second. And you can configure it. So for example, you can see an example of configuration based on request-based autoscaling. You can see that my service got a new configuration. I can scale the policy to say that I want to get a concurrency of 6 pods, and each one of them has a target threshold of 70% utilization of the CPU. In any case that my pod autoscaler will get the metrics from the pod and understand that this threshold had been reached, he will spin up more pods. And again, this gives us much more flexibility when we manage our infrastructure. And this is an example of this. Another very important thing, as he said in the newsflash, is, again, we have a lot of instances, but again, how are we going to handle them when there is no communication, okay? There is a budget cost here, and the solution itself must be providing a solution where your traffic is idle. And this is also something that's managed by Knative serving. The scale to 0. You can manage a policy, and here you can see as a grace period, that the autoscaler listens into your traffic. And by this example, after 40 seconds of inactivity into your Kubernetes ingress carrier or any other ingress like Istio or any other ingress you can use, he will scale down the cluster and remove the pods. So it's fully capable to handling a burst of traffic, but also handling an idle of operation into your services, which is the fundamental of running serverless computing. And this is a scale to 0. Another thing, as I mentioned, you need to give the ability to manage deployments, not just saying, okay, 100% of the traffic need to be managed in the new version. You want to do and manage it by gradual policies. And to do so, you can get, for example, as you say, day 2 or blue version. And just to get an example, blue-green deployment, you decide that you want to deploy a new version, but only 50% of the requests need to be routed into the new service. So to do so, it's really, really simple. You just create a new configuration. Under configuration, you're creating a route element. And in the route element, you're tagging your version. And as you can see here, each one of them will handle 50% of the traffic itself. And again, this is something that cannot be achieved if you're using Kubernetes right now to manage your workloads. This is very important thing to say. We do not replace, Knative do not replace Kubernetes. It's just wrapping up some kind of an abstraction level behind it. So you create in Kubernetes create service, you create configuration, you tag it with a revision, but underneath it, when you run Kubernetes, both eventing and also serving, you're still creating and spin up a deployment, a replica set, and of course, a pod to manage your compute resources allocation. So this is really, really important. We do not replace Kubernetes itself. Knative eventing is also a very, very important thing as part of the Knative solution. We do understand that serving and all the challenges that we saw right now, it's super important, but a lot of serverless-based traffic is managed by an eventing, trigger an event using some subscription-based model, handling traffic and triggering it is very important part of the serverless solution. And to do so, Knative also introduced another product called eventing. Eventing means that you can handle any kind of a traffic based, for example, on a cron job. It could be a Kafka, it could be an S3, some kind of event got from S3. It could be an mixed with Hebrew and English, an S3 event, bucket update event, cron job, Kafka stream, SQS, a webhook, for example, if you push code in GitHub, and a lot of event handling systems. And the basic foundation of managing traffic on an event base is using a standard called cloud events. Cloud events is a standard to manage every aspect of sending and managing events. It could be an IoT event, it could be public cloud, gateway, function as a service, public cloud, and SaaS. And it's basically just a JSON. As you can see here, this is kind of a JSON, which represents a message. The message itself, you can see you have the source, you have the subject, you have a data, data or metadata you can get inside of it. The data is a payload itself, and metadata is going to be also part of the message itself, and you have the ID. And it's really important because all of the above, as you see here, are supported this kind of messages. So it's going to be very easy for you to write a subscription element on one end and subscriber on the other end, push and receive messages with the same format. They all support this format. And how it looks like. Let's say, take for example, a simple design of channel subscription, which will support one of the models supported by Knative. You can get an event into the Knative logical channel. You can get the event from, again, any system, let's say SQS, you can get the event from there. And then you can invoke your own function to handle this event. And for example, you can create a channel in Knative and create 2 subscribers and 2 functions. One of them going to handle a message type number 1, and the other one is going to handle message type 2. And how it looks like when you're creating the configuration. So in this example, you can see a cron job source, which is an example to run your own mechanism to generate your own messages. It's really good if you're using it in your development environment. And as you can see here, every minute or so, there's something here you can see I'm sending a message, and it's really simplistic one. The payload is just a message, hello world from the cron. And this is one element that can I create inside the Knative itself. Another one, as we said, is a service. And in this case, the service is not evoked by an HTTP request, but it's rather invoked by an event coming to the system. Every event, if the subscriber decide you need to handle it, it will invoke this function. The channel itself, and as I said, the channel itself is the foundation of, for example, in this case, the pub subscribe element. So he will handle the relay of all the messages. And you can say, I want to create a ping source. And in this case, in every 2 minutes, I will send an event, some message into this sync. As you can see here, this is a subscription, and it's really, really simplistic. The subscription, I'm just saying, okay, I want to listen into channel event hello. This is going to be my broker. And in any case, I'm getting a specific message, please run this service itself. This is how you close the gap. So I think to conclude this part before going to function, Kubernetes and Knative bring a lot of benefits running together when running Lambda, let's call it not Lambda, serverless workloads underneath Kubernetes. And in this case, I would like to show you a quick demo about the latest project of Knative called Knative Functions. Knative Functions giving us the ability to really simplify the model because as you saw right now, it's still complex. And I think what Knative Functions aim to do is really simplify this effort. So let's try to create a very simple Lambda function or Knative function. What we're going to do is something like this. We're going to run the CLI, okay? And in the CLI, we'd like to start the Quarks project, demo project. So I will run func create. I can see the option relevant here from Go, Node, Python, Quarks, Spring Boot, and TypeScript. Let's create an application, okay? So func create, and the language will be course. The application is going to be Java.IL func1, and I just created an application. Let's open the application. You can see here, this is a template created by Knative. It's really, really simple, and it's really optimized to use the serverless functionality with quirks. As you can see here, I have just 3 objects, function, and here I represent my business logic, input and an output. And to be correlated, we have 2 functions. One of them is a unit test function, and with rest assurance, we have an integration function. And let's just write our business logic, see how simple it is. So let's say I want to check this is a valid object. And again, sorry for simplicity. And if it is, I just want to change it and say input, get message to uppercase. That's all. And if not, just return empty. Okay? This is my business logic. I would update my test and make sure this is in a capital letter. Make sure also my integration test is okay. And let's check it. I go to the terminal. And again, this is just the Java project Maven test. I can see here, ooh, damn. See Java Summit function. Let's run it. Maven test. Let's see that the function is working. I compile it, and the test will complete okay. As we can see, test completed, both of the unit and the integration test. And what's the next thing? The next thing we'd like to check is how's the configuration of the function itself. This is a pre-baked example. So I already pushed the Docker image as part of the development of my Knative function. But as you can see here, I see the application name, I can see the registry, I can see the specific tag of the image itself, the digest ID to make sure that I don't need to rerun it if nothing changed. I can get a lot of information about how you're packing it, okay? I can see information about the build environment, specifically for Maven, Gradle, etc. on the JVM itself when we're running the application itself. And also I can see some kind of policies that I can scale. So for example, I can decide that I want a scale policy of minimum 2 instances. And this Lambda function, when it's going to be heating up, is going to be serving at least 2 pods in order to fulfill the need of the function. But let's try to simplify it. So the only thing after doing so is let's see the function possibility. I just need to build. And again, in this time, I don't want to push to Docker registry with its Wi-Fi. Let's assume it's happening, but it's really simple by just running the build, and it automatically will be pushed. And then I want to test it locally. To test it locally, all I need to do is func, just run, func, run. And again, I'm going to skip the build. And as you can see here, in half a second, the Quarks process is initialized and it's working. You see here, I have an instance and it's running. From here, let's try just to, let's just try to run it locally, remotely, just to show you guys, it's really, really important. Func deploy. I will skip the deployment. You can see here, I just deploy it in my Kubernetes cluster. Okay, func info, see the details. And let's say I want to check for bus traffic. I'm going to send for 10 seconds 200 concurrence requests and see how this function handles it. As you can see here, I invoked it. And by the end of the command, I will run kubectl getSpot to see what's happening. Because as you remember, my scale policy was 0. Before it running, there was no pod as part of the function. And as you can see here, it's super important. The auto-scaling service is scaled up for 2 instances. And you can see in a histogram of how was the response time. But what's more cool, that if I'm going to run the watch command, I can see it was terminated. And if I'm going to run this again, okay, but in the background, and also we'll run again the watch pod, it's already created. So it's really behind the scenes running your pods and optimizing it based on your needs. So it's really, really important thing here. And just to finish, you just need to run func remove and func delete, and you just removed your workload from your Kubernetes cluster. That simple, super easy, and I think it's really, really amazing project for all of us to invest and learn. Thank you guys for your time.